Okay, so before we get into area and volume of 3D figures, we need to make sure that we know how to classify these figures so that we can find the accurate volume and surface area for them. So we are going to look at prisms, pyramids, cones, cylinders, and spheres. So if you look here at what a prism is, so it says a prism is a solid with two bases that are congruent and parallel. So the bases that it's talking about is, in this picture I'm just going to shade a little bit, is the top and the bottom. These are the bases that it's talking about. They are congruent, they're the same size, and they're parallel to each other. Okay, so that is what a prism is. It says this figure is a triangular prism because its bases are triangles. You can classify them by their bases. Okay, so let's look at pyramids next. A pyramid is a solid with one base and faces that meet at a point. So here's the one base. I'm going to highlight it. And the faces all meet at one point, which is this point at the very top. This figure is a triangular pyramid because the base is a triangle. Classify it by its bases as well. Okay, a cylinder is a special type of prism. Okay, its bases are circles, so we call this a cylinder. It's just a special type of prism. Okay, a cone is a special type of pyramid where the base is a circle as well. It meets at a point, so it fits the definition of a pyramid. And then a sphere is a solid in which each point is equidistant from the center point. So every point is the same distance to the very center point at any given place on the sphere. Okay, so this is how we classify our figures. So if you look at number 1, we're going to classify these and we're going to highlight the bases just like I did up top. So number 1, I'm going to highlight my base. What is that base? It's a rectangle, right? So we're going to call this a rectangular. It has a point where all the faces meet, so this is a rectangular pyramid. One base meets at a point. So this is a rectangular pyramid. Okay, the next, I have a base here, it's a circle. Meets at a point. So you can obviously tell that this is a cone. Looks like an ice cream cone. Okay, number 3, I'm going to highlight my bases. They are congruent and parallel. Those bases are triangles, so this is a triangular prism, two bases. Okay. Number 4, I'm going to highlight my base. They all meet at a point, so I know automatically that this is a pyramid. If you look down bottom, the base has 1, 2, 3, 4, 5, 6 sides. So this is a hexagon base, so you're going to call this a hexagonal pyramid. Number 5, the bases are circular, and there's 2 of them. So this is a cylinder. Okay. Number 6 technically could have 2 sets of bases. They could be the sides because those are congruent and parallel. Could be the top or the bottom. Could be the front and the back. So you could technically shade multiple things. I'm going to, in this case, just shade the top and the bottom. It would work either way. So I know that these bases are rectangles, so you're going to call this a rectangular prism. Okay. Number 7, The bases here, they have to be congruent and parallel. So the top and the bottom, they're not congruent. The sides on the left and right hand side, they're not parallel. So the front face and the back, those are the bases. Those figures are trapezoids. So this is called a trapezoidal prism. Okay, I'm going to let you finish up the last few on your own in a little bit. We're going to go on to the next page. Maybe. Okay, the next page, we are actually going to look at prisms, and we're going to figure out their surface area. So if you look at your notes, it gives you the formula off to the side, and it explains what each letter is. It shows you where the length is, where the width is, and where the height is. So for a rectangular prism or a cube, this is the formula that works. So our surface area formula, it seems really long. It's not too bad though. It's 2 length times width plus 2 length times height plus 2 width times height. Okay? So we gotta use that formula on all of these to find the surface area. So my surface area, I'm going to take 2, my length, really it doesn't matter which one you get in which space. If you want to, you can call this the length, this the width, and this the height. Doesn't matter if you switch them up as long as you plug them in the same way every time into your formula. Okay, so that's how I'm going to label it in my picture. So 2 length times width would be 2 times 7 times 13 plus 2 length times height would be 2 times 7 times 9 plus 2 times width times height would be 2 times 13 times 9. Just plugging it in. So if you multiply all of that, type it all into your calculator, you are going to end up with 542 feet squared. It is area, so it is squared. So number 2, start by labeling. I'm going to call this the length, this the width, this the height. And I'm going to plug in 2 length times width plus 2 length times height plus 2 width times height. And plug it all in. So you're going to end up with 580 centimeters squared. I'm going to leave number 3. We're going to look at the formula that works for any other type of prism. So this formula only works for rectangular prisms and cubes. It doesn't work for anything else. So if you have a triangular prism, trapezoidal prism, something like that, this formula is what is going to work. Okay, so what we're going to look at, I'm going to explain. It gives us 2 formulas here. It says first find the lateral area. It says the area of the non-bases, and then add the area of the bases. We are just going to mainly focus on this formula, this surface area formula. What the lateral area is, it does not include the bases, okay? But we're going to include the bases on our formulas. So we're going to use just this, mainly we're just going to use the surface area formula. And I'll show you a little bit later on in some lessons where we'll only find lateral area. For right now, surface area is what we're finding. So what that is its height between the bases. That's what H stands for. P stands for the perimeter of the base, and B stands for area of the base. Okay? So we need 3 things in these. We need H, we need P, and we need big B, which stands for area of the base. So I'm going to write that down. H, P, big B. H, P, big B. Okay, that's what I'm going to find first on all of these. So h is the height between the bases. Shade the bases so that you can tell which ones they are. Here's one base. Here's two base. Now the height between them is the line that connects the two of them. So this is my height between my bases. It is 16. Okay. Now my perimeter is the perimeter of the base. So I have to take all of the sides and add them together. So this one's 9, this one's 12. This one is the same as this, so it's 15. So I'm going to add 9 plus 12 plus 15 to get 36. That's my perimeter. And then my area of the base, I have to first figure out what is this base. It's a triangle, right? The area formula for a triangle is 1/2 base times height. So if you look at the triangle, the base of that triangle is 9. The height of that triangle, we're only looking at the base, is 12. So if I multiply those, I end up with 54. That's the area of the base. Now I'm ready to use my area formula, my surface area formula. So my surface area is going to be 16 times 36 plus 2 times 54, which ends up giving me 684 meters squared. Okay, let's look at number 5. So number 5, we need our height between our bases, we need our perimeter of our base, and we need our area of our base. So our bases are the front and the back of this figure. So the height between them is going to connect them right here. Okay, which is also connecting them right here, which is going to be 3. Now our perimeter of our base, they're triangles. I've got to add up the sides. I've got to add up 5, I've got to add up 12, and I've got to add up this side, which is 10. So 5 plus 12 plus 10 is going to end up giving me 27. Now my area, my base. Now that is a triangle, so 1/2 base times height is the formula. So if you look at just the triangle there, okay, we are going to take the base of that triangle. If you look at that, we're going to have the base being this and the height being this that's drawn in from the top to the bottom of the figure. So the base of the triangle, where the height connects to the base of the triangle, is going to be 12. The height of the triangle is 4.1. So when I plug all of that in, I get 24.6. And now I can plug it into my surface area formula. So surface area, height times perimeter, plus 2 times your base. And I get 130.2 kilometers squared. Let's look at number 6. Okay, so for number 6, our bases are the front and the back of this figure. So the distance in between those, the height between my bases, is going to be 15. The perimeter of the base, I've got to add 12, 23, 20, and 18. So 12 plus 23 plus 20 plus 18. All together is going to give me 73 as my perimeter. So now my area of my base, if I look at my base, it is a trapezoid. The area formula is 1/2 height times base 1 plus base 2. Should have your formula sheet in front of you, or you should have these formulas memorized like I do. So I have 1/2. The height of my trapezoid is 12 feet. My bases of my trapezoid are 18 and 23. When I plug that in, I get 246. So my surface area, height times perimeter, plus 2 times my base. I get 1,587, I believe. Let me make sure. Yep, 87 feet squared. Okay, flip it over, look at number 8, and then we'll look at cylinders. If you look at number 8, you still need your height, your perimeter, your area of your base. So your height between your bases are in the front and the back. The height between them connects them, that's going to be 21. To get your perimeter of your base, you gotta add all 3 sides, but it doesn't give you this third side over here. So you need to find that third side, and it's a right triangle, so you could find it by using Pythagorean theorem. Do 8 squared plus 15 squared equals x squared. If you do that, add those two together, you get 289. Take the square root, you get 17. This side is 17. So add those all together to get the perimeter of the base. 8 plus 15 plus 17 to get, let's see here, 40. Alright, now we're going to find the area of our base. Our base is a triangle, so the area formula is 1/2 base times height. So the base of my triangle is 8. The height of my triangle is 15. And I get 60. So now I'm ready to get my surface area. Height times perimeter plus 2 times my base. And I end up with 960 inches squared. Alright, so let's look at some cylinders. These are easier, much easier in my opinion. We're going to find the surface area of them. Now the lateral area will give us just the area not including our bases. We will use that eventually, but right now we're just focused on our surface area formula, so put a star by that. We need our radius and we need our height. Those are the 2 things that we need. So on number 9, here's my radius and here's my height. So I have the 2 things I need and I can plug it in. I'm going to start with 2 pi times my radius squared plus 2 pi times my radius times my height. Okay. So when I plug all of that into my calculator, I get 2,557.26 yards squared. Okay. So look at number 10. So on number 10, you know, your radius is going to be half of this. So your radius is actually going to be 7.5, and this is your height. So if you plug that in, you have 2 pi times 7.5 squared plus 2 pi times 7.5 times 9. And I'll let you plug that one in and figure out the rest of it later. I want to look at a couple application problems. So if you look at number 11, it says if the surface area of the box of cereal below is 272 inches squared, find the length of the box. Well, what is this figure? What kind of figure is this? It's a prism, right? It's actually a rectangular prism. So our surface area formula is 2 length times width plus 2 length times height plus 2 width times height. So I'm going to take this surface area that it gives us and I'm going to plug it in. I get 272. Now it tells me that I do not know the length, but this is my width and this is my height. So I'm going to replace width and height with those two numbers. So 2L times my width, which is 2, plus 2L times my height, which is 12, plus 2 times 2 times 12. I'm going to clean this up just a bit. So I'm going to multiply what numbers I can. 2 times 2 is 4, and then I have an L. Plus 2 times 12 is 24, and I have an L. Plus 2 times 2 times 12 is 48. Now I'm going to combine my like terms, the terms that have L's with them. So I have 272 equals 28L plus 48. This is just an algebra problem that I'm solving for L. Subtract the 48. And I get 224 equals 28L. So to find L, I have to divide by 28. So my L is going to be 8 inches. So let's try number 12. It tells me that the surface area of the can of soup below is 51.84 inches. The diameter of the can is 3, so that means my radius is 1.5. I don't know my height. So my surface area formula for my can of soup here, it's a cylinder. So my surface area formula is 2 pi r squared plus 2 pi r h. And I know that surface area formula is going to be equal to 51.84. So let's replace our numbers where we can. 51.84 is the surface area. I know my 1.5 is my radius, but I don't know my h, so it's going to stay h. But I'm going to clean it up where I can. I'm going to calculate this 2 pi times 1.5 squared. And I'm going to round it. It's going to be 14.14. And then I'm going to multiply these numbers, 2 pi times 1.5. And this gives me 9.42h. So an algebra problem just like the last one. I have to subtract this 14.14 from the other side. So 51.84 minus 14.14. I get 37.7 equals 9.42h. And I have to divide the 37.7 by the 9.42. So that tells me my height is 4 inches. Okay, so the problems that we did not do, that we didn't complete, that's what I want you working on until the bell rings. Make sure that you are quiet and working.